I am now joined by Carina Bennet, um, a faculty member at the University of Arizona and one of the imaging team members of the OSIRIS-REx mission, and one of the people responsible for helping me torture our entire CosmoQuest community with all the rocks, boulders, and craters on Bennu. How are you feeling today?
Well, today is incredible. It's been an incredibly stressful week, exciting week, but today is the first day that I feel like I've actually gotten to relax, which is nice. Um, yeah, I assume you guys have been following the OREX news.
And what I haven't had time to talk about on camera yet is how much stuff you guys stuffed into your instrument. So on Tuesday, OSIRIS-REx descended down into Nightingale Crater, went to boop the asteroid, and I think you punched it instead.
Mm-hmm. It was a little aggressive.
Can,
Um,
can you describe this? Because I'm
yeah,
just going to
so
giggle. I have to admit that.
we have images of this on Twitter and on Instagram. So if you guys want to go there, you can definitely see them if you haven't seen them already. But basically, we approached the asteroid. We were going incredibly slowly. We had our arm extended, and we kind of expected that we were going to hit the asteroid. Didn't know exactly, what was going to happen because we're just, trying to figure out what Bennu is made of. And what happened is we kind of sunk into Bennu. Rocks went everywhere. It looks like a massive explosion. We pulled away and we imaged the sampling mechanism, and we saw that it was just like completely, not only completely full of rocks, but it was actually kind of spewing rocks and losing rocks. So today we decided to stow it instead of doing some of the more kind of eventful maneuvers to see how much sample we got, because we were worried about losing more sample. So we
Yeah.
decided that we're just going to stow it. We know that we have enough. We're very confident.
I
Yeah, so it seems
I
like a
heard
complete success.
I heard guesses on Twitter, which means Lord only knows how true they are, um, that it could have been as much as half a kilogram of material was caught. Can you say anything to confirm or deny those rumors?
We don't know. We have guesses internal on the team, but since we didn't do a lot of the tests that we were going to do to determine how much, we're not positive, but it definitely, it looks jam-packed. So it's definitely more than 60, which is kind of all I can say.
And that is awesome.
Yeah.
Wait, what? Wait, hold on. We just got a donation of $2,058.
Wow.
Okay, so that is more than enough that 3 dogs are about to get bacon. I only have 1 dog on hand. Can you talk about Bennu? Okay, I have a second dog. Grigory, can you go find Eddie? Like, don't give him this bacon, but lure him with this bacon. Okay, he'll just come. Okay, so I'm gonna work on setting up dog cam if you can talk about the glory of how full the tag device is.
Yeah, definitely. So, one of the things that we did before we did the sampling is we actually imaged the sample head when it was empty. And so we positioned it against the sun in the same with the same angle of the arm that we were going to position it when we actually had the sample inside of it, so that we could make direct comparisons between an empty sample head and a full sample head. And one of the things that we noticed, because we can't see necessarily everything inside of it because of the way it's shaped, we need to keep the sample
Yeah.
inside of it. But one of the things, if you look, we have an image of the empty sample head on our website, asteroidmission.org. And you can see light streaming through kind of like the back of the sample head, and you can see like some of the mesh. And when you look at the images with the material inside of it, you can't see any of that light streaming through it, which is a really good indication that it is just completely chock full of material.
Wow.
Yeah, it's absolutely incredible.
And this world had previously focused mainly on disappointing and upsetting us. And
Yes.
like everyone's heard my story of just basically having a slow and increasing heart palpitation and anxiety attack as the approach images came in.
Yep.
Can you tell your side of the story? Because you were the other person who was like, oh God, database, my database will die.
Yeah. So one of my responsibilities on this mission was to have a team of people who are going to count every single boulder on the surface. And we went into this thinking that we could get it done relatively quickly, that there would be a bunch of really big boulders, and mostly it would be just like a gorgeous sandy beach looking, like tiny particles that you can't even count because they're just so minuscule. And yeah, I mean, we got there, we saw the initial just point of light, and every day we got a little bit closer, and we saw Ben, which was the big boulder in the southern hemisphere, which we expected. And then we saw a few more big boulders, and every day we got closer and closer and realized that everything we were seeing were these massive boulders. And the closer we got, we realized it was just basically rocks all the way down, which was terrifying for me.
Yes.
Of course, we ended up, changing the requirements.
I'm adjusting things so that we can give dogs bacon. I can hear your
Okay,
story.
I don't want to stand in the way. Yeah, so we ended up adjusting the requirements. We ended up focusing our internal team of counters on just the regions of interest, the potential sample sites. So these were the craters that kind of looked smoother than some of the other areas. So we focused our internal team of counters on that. And we relied on the CosmoQuest counters to do this massive global count, which we're still processing. I am still processing. And that's mostly just because I have other mission critical requirements, but we are working on those. And yeah, it was, you have confidence in your team, but yeah, seeing something like that, it does make you worried.
It
Oh,
does. And we're going to have a moment of pure, unadulterated joy because even in 2020, unadulterated,
yeah.
pure joy still exists. I present you with 120 pounds of happy furry wiggle butts. Look at this. What's this? Come on. Come on. Are you seeing this?
They look thrilled.
Okay, we don't have enough wiggle butt. We don't have enough excitement. Come be excited. Come be excited. Come on, sit. Come on, let's do another dance. Let's do another dance. Come. Oh, Eddie, come over here. Come over here. Unadulterated happiness. This is what we are about. We are about unadulterated happiness. Come here. Bounce. Here. Can you jump out? Can you? You're off camera. Unadulterated happiness. Here we go. Oh, we are out of bacon, but we can still bounce. Come on. Come on. Come on. Good dogs. Good dogs. Good dogs. Good dogs. Good dogs. Okay. Okay. That was enough excitement. All right. So I present you unadulterated happiness in the name of science. Um, so, Karina, was there unadulterated happiness on Tuesday?
Yeah, there absolutely was. We were all not a small portion of the team did manage to get together safely, um, you know, with masks and social distancing, and we were able to kind of like watch in real time as everybody else was watching the NASA broadcast. Um, and yeah, seeing, you see on the screen, you see Dante speaking and he's listening and he's waiting, and then you can kind of see we had a screen where we could see all the other rooms where people were working, and it was almost like a domino effect, as you could see the different teams learning that it was successful, where you could see in one square people just erupting in cheers, and the next square people would erupt in cheers, and then it got to Dante and he was thrilled, and then the announcement, and so our entire team was cheering. So it was, yeah, it was an amazing moment for all of us.
And there's been a whole lot of moments of holding our breath.
Mm.
We were both at the launch down in Florida, although in very different places. And there's few things as scarier as a launch. Then there was
Yeah.
the will it come into orbit correctly? And it
Mm-hmm.
did. And
Mm-hmm.
then we learned Benny was throwing rocks at us. And then it was is it safe to approach? And
Yeah.
now we just have to worry about it getting home.
Mm-hmm.
So, what's the story from now to the end?
So it's yeah, it's going to, I don't actually have it off the top of my head the day that it leaves the asteroid, but it should be returning to Earth. And during that time, it's going to be another kind of team transition. We had the team that built this. Well, we had the team that wrote the proposals,
Yeah.
and got the funding, and then we had the team that actually built all of the spacecraft, and the instruments, and then now we kind of have the team that's operating, the spacecraft and doing the science. And so there'll be another team transition where we transition kind of to the sample scientists and building up the infrastructure that they need to actually analyze the sample when it gets back. Um, and so luckily I am on that team. So I'm going to start building kind of like a whole database system, to organize the sample, to make it extremely streamlined so that we don't waste any time when we get it. We
Good.
don't waste any sample. Yeah, and then it's basically up to it's kind of like looking at the instruments that we had kind of on Earth and orbiting Earth.
Yeah.
And they took data and made, analysis of what Bennu is made of. And then we got close to the asteroid and we used similar instruments on the spacecraft to kind of figure out what Bennu is made of. And now we actually are going to be able to physically look at Bennu and do the measurements on Earth and see how accurate our instruments that we're using on all of these asteroids all the time actually are, which is going to be extremely useful.
And one of the things that just totally floored me is as we had our citizen scientists going through the images, people started pinging me and saying, "Hey, what are all these shiny things?" And
Mm.
your team was doing the exact same thing. "Hey, what are all the shiny things?" Okay, what are the shiny things?
Yeah, definitely. So there was a paper that came out, and essentially a lot of them are pyroxene, and they think that these are boulders that maybe came from Vesta,
Yeah.
um, and yeah, kind of collided with Bennu and have lived the rest of their lives on Bennu. And we're hoping that we get some collection of different types of materials during collection. We can't guarantee that we're
Yeah.
going to get one of those shinies, but that would be extremely exciting.
And it's this asteroid has had a hard life. just the fact that it appears to be a mixture of three or more objects. Is that a correct reading of the paper?
That could be. This is not, I am definitely more on the engineering side.
I'm on the database
So I
side
don't
too.
want
It
to
was just the
speak.
fact that we found shinies and they appear to be from
Yes.
Vesta. And how do you get a rubble pile? I love my database. I need to
Yeah.
talk more to Danny.
Yeah. It's definitely a collection of, I mean, it's a rubble pile. It's a bunch of things that got collected together and kind of stuck together. So, yeah.
Essentially, a dump truck in space
Hmm.
dumped its load and left us an asteroid.
Yeah. That was rocky, craggly, terrifying asteroid.
Yeah, yeah. So
Terrifying for
so
rock counters.
we had Eric Palmer on earlier, who I'm guessing
Mhm.
is one of the folks that you work with, and he was talking about the shape models and how everyone's working to try and get all the data put together in a coherent manner. And I know
Mhm.
this is something that keeps proving itself to be far harder than anyone anticipated going into
Mhm.
this. Is the mission still taking data? Do you still have an incoming flood of, oh dear, how do we deal with this? Or are you pretty much now just in the making sure everything is stored and safe part of the mission?
We we've definitely slowed down on taking data. I mean, one of the things we wanted to do is not stress the spacecraft or the team right before tag.
Yeah.
So there wasn't a lot of science investigations and data taking before. And now, of course, we want to keep the sample safe and make sure it gets back. So we're not going to do a lot after, but I'm sure Eric talked about how, I mean, we've really never taken global data at this high of resolution of an object
Right.
before. And,
Seven
you know,
centimeters. Like
yeah,
this big.
yeah, it's insane. And I mean, it's a big asteroid. It's a lot of data. And so it's a lot of processes that we haven't tested before. And of course, we're all working as the mission is going. So
Right.
not only are we trying to process the data that we already had, but we're planning for the next data, and we're making sure that everything is safe and everything makes sense and everybody's data is agreeing with each other. And so one of the things that we are always doing is going back and saying like, oh, here's something new that we learned. Let's look at what we've already done and make sure that it still makes sense, or if we can improve it some way, we definitely want to improve it. So there's people who are still looking at the data from previous mosaics, previous imaging, and taking the new data and re-registering those images, recreating the mosaics, and just making them better and better. It's, it's,
And
it's never ending.
what really got me about this mission, and it's a testament to the flexibility in the software that was written for this mission, is it was originally planned that going down into Nightingale Crater, it wasn't, they didn't know it was going to be Nightingale Crater. It was originally
Mhm.
planned that when the mission went down to boop the surface and grab the sample, that it would be laser altimetry. They'd be bouncing a laser off just like a Tesla
Mhm.
does to figure out how far it is from the car in front of you. And that laser would be good enough. But in the end, they ended up having to use computer vision.
Mhm.
And how how? It's I can't do anything more with that sentence other than how.
Yeah, I mean, that is definitely a testament to our navigation team. They developed natural feature tracking kind of as the mission was progressing. And I can't even imagine the amount of pressure that they were under. Um,
And the
because
spacecraft did this
essentially,
autonomously.
yes, yes. So basically, we created a internal hazard map, um, where we took a bunch of features that we knew where they were based on imagery and the stuff that Eric's group was doing with the shape model before.
Yeah.
And we said, like, you know, these are the objects, we know where they are. And as the spacecraft was going to take the sample, it would kind of make an internal map, and then it would take a picture and it would say, here's where I think I am based on this internal hazard map, and then look at the picture and say, well, here's where I actually am. So I know that I am, you know, this much off in this direction or this much off in this other direction, and it would do minor corrections. And the other thing that it could do with that is it could say, which it didn't, but it could say, I am going to approach a hazard. It's going to put me in danger. If I go any farther, I'm going to be in trouble. So it could actually do a wave off, and it could have not done the sampling. So which would have given us a chance to do sampling some other time.
Now,
Yeah, it was incredible.
Yeah, the entire descent and fly away was essentially an hour and a half after deorbit.
Mm-hmm.
And it was like order of 18 light minutes away at this point.
Mm-hmm.
So it was already a third of the way through whatever you thought it had done when we got the signal.
Yeah, I mean, we really needed to trust, which we did. We needed to trust our planning and our engineering and the spacecraft and the people who built it and the people who wrote the software, and it all worked out unbelievably well.
And
But yeah, we were just waiting to hear what happened.
Mm-hmm. And what gets me about this mission is this isn't one of NASA's giant flagship missions. This didn't involve massive corporations and bid out contracts at the massive levels. This is University of Arizona, JPL, a suite of institutions and individuals that, I mean, you all fit into a restaurant together at launch. And what's it like to be a small team taking on a small rock and doing such enormous science?
It's almost hard to wrap your head around. I mean, I remember when I started on this mission almost 6 years ago,
Yeah.
I was doing a second undergrad as a kind of an older student, and I got this job as a part-time research assistant on the OSIRIS-REx mission.
Yeah.
And I knew it was a NASA mission. And I knew it was a big deal, but it felt like a small team. It felt like a small community.
Yeah.
And I remember that, like, you know, people around me, it didn't have any clout. It was kind of like an interesting thing. And then of course launch happened and it got in the news and it got a little bit bigger. But the team stayed the same. It was still the same people that were working on it. Kind of not in the shadows, but
right.
You know, without all the attention. Yeah, it feels like, I mean, these are my friends. These are my almost like a family now. Like we spend our weekends together. We would spend our weekends together. We would go out. These are the people that I want to spend my time with, not the people I have to, which is amazing.
Right. And this is a super young team.
Yes.
Dante's the youngest mission PI that NASA has had. And I just realized that we've been talking since the dogs with me having a super tiny little video. Let me increase this so we're about the same size talking to each other. You were temporarily talking to someone who had gone through the Honey, I Shrunk the Kids Ray. It's a super young mission. There have been, the person who pulled me into this was a graduate student that said, hey, I think we have a good opportunity for citizen science. Do you want me to introduce you to some folks? This was Hannah, who's also a long-term member of the Astronomy Cast community. And it's the creativity that's cropped up along the lines with such a young team has just been amazing to watch. Where do you go from here?
I mean, hopefully we all continue working in the space sciences. We can continue making discoveries. I think that a lot of us have created bonds with each other, and you know, we're always inviting each other to work on each other's proposals, trying to figure out new science that we can do and ways that we can get it funded. And I don't think that the University of Arizona is going to stop searching for this kind of science. And it has been so supportive of the students. This mission has been so supportive, the Lunar and Planetary Lab, of finding students who are interested in this kind of work, getting them on the mission, and then getting them jobs either with OSIRIS-REx or with one of our institutions that have been working with us. And so it really does feel like they're creating a whole new generation that's hopefully going to be doing this for a long time.
Something that was unique for me is all my mission contacts were women. And that just is how it happened. And you're the only other female planetary science computer jockey I know. And it's just been a pleasure to get to periodically go, oh my God, it's killing my database. Oh, I know.
Yeah.
None of the software we spent years testing and testing and testing was up to the reality of that.
Yeah.
So we did it. And they won't destroy our databases any more than they already have. The worst has already come.
Yep. Yeah, we can't do anything else to those poor things.
No,
but yeah, it has been. I remember when I started. When I started computer science, because I started it later in life. Yeah. I had an art degree and a film degree before that. One of the things I was most worried about is that I was going to lose kind of like the female community and the more diverse community that I had grown so fond of and relied on in the arts. And it was terrifying. The first computer science class I had 300 students in it, and 10 of them were women. So I almost went into this field with trepidation.
Yeah.
I was extremely nervous.
Yeah.
And I can't believe that the first job I found, I had multiple female bosses. The deputy PI of the mission is an incredibly strong, brilliant woman. Almost my entire team is women. We have more women than men. And yeah, you feel respected, you feel listened to, you feel absolutely like you belong.
Yes.
So yeah, I feel like I absolutely lucked out with this mission and this team.
And this is not something we're used to in our field, and it's really it's awesome.
It's special. Yeah.
Now, before I ask you to describe what all is going to happen to that sample, I'm going to take a moment for a station identification. To those of you just tuning in, this is the CosmoQuest Hangoutathon 2020. We are here streaming for 36 straight hours. We are now in the process of finishing hour 13. We are working to raise money for science education, and communication. And we've created a place with CosmoQuest where you can come and find science, learn science, and find community. We were part of a myriad of people who studied Bennu in a variety of different ways to try and find that safe place for, it turns out, OSIRIS-REx to punch an asteroid. We will be here through the night, and we'll be bringing you a scale model build of the solar system, including a not to scale version of Bennu, because Bennu to scale was too small. We're bringing you a scale model of the solar system getting built in Minecraft in tribute to our recently passed away community member Paranor 001, Tim Hawkins in real life. So A Middles asks, does Pamela ever sleep. I think I saw a caffeine drip on the side somewhere. I'm actually drinking jasmine tea at this point. And in the next hour, Annie Wilson, our host for Rocket Wednesdays, and Beth Johnson, our host of Planetary Pandemonium, are going to take over for the evening. I'll be around for a little while, making sure everything is going smoothly, but I will be sleeping because I like myself. I think that's the reason. So Karina, your spacecraft is coming back with who knows how much debris from the asteroid Bennu. It's going a bit of it to JAXA in exchange for a sample of Ryugu. It's going a bit of it to Canada because they built the laser altimeter that wasn't as necessary as thought, but still provided excellent data. Uh,
Absolutely.
and then Arizona's getting a large chunk of the sample. And what does your future cataloging laboratory process look like?
Yeah, so that's actually really exciting for me because I'm on the team that's building the whole kind of digital database infrastructure for that. And so what's going to happen when we get the sample back is that the OSIRIS-REx team kind of has a 2-year exclusivity opportunity with the sample. So they get 2 years where they're the kind of the only ones who get to do any science on the sample and have access to the sample. And so we really want to maximize the, the number of our scientists who can use the material, the way that they share the material and their data. We want to make that as streamlined as possible. So we're building a system that is based off of GIS, which is Geographic Information Systems. And so these are kind of the spatially aware database systems, ways of acquiring data, algorithms, and different software that can actually process spatial data very quickly and intelligently. So we're treating these samples as tiny little geographic worlds, and we're going to treat the thin sections as maps. And we're going to use this kind of Earth-based giant world-focused system, and we're going to use it at the microscopic level. So a lot of what we're doing right now is building that system and trying to figure out the little tweaks that we need to make to it. So we're not going to be using latitude and longitude. We're going to have to use a different type of coordinate system. And each of the different instruments, we're going to have to do little tweaks. So that's what we're spending the next few years working on. And hopefully it should make everything extremely efficient
Now,
and easy for people to use in the future.
one of the things I did as what is best described an internship as a middle schooler,
Hmm.
unpaid slave labor for the company my dad worked for, I think is how I viewed it at the time. Was his company was working on reverse engineering some microchips, and my job was I had a microscope that I had to scan to a section, shift through and take an image at a myriad of different focal heights to get different planes in the chip, shift to the next overlapping section, and repeat taking all these. Are you going to be doing something, hopefully with an electronic system instead of a middle schooler? Are you going to be doing something similar to that with these sections that you're getting?
Yeah, definitely. I mean, each section, it has so much information, and each instrument can extract that information in different ways. And so each little tiny bit is precious, and we're going to get as much out of it as possible. And so we want to be able to take a thin section and then do, individual pieces of that, smaller and smaller, all the way down to atoms, and then be able to organize it and search it
Wait,
and visualize it.
did you just say all the way down to atoms?
Yes. Yes, I have seen it. Not with the sample, obviously, but I have.
So
It was,
what that's not an optical microscope at that level. What technology are you using to do this? And can I have
So,
some?
so this is based out of the University of Arizona, and they have a massive microscopy lab with a
Uh-huh.
bunch of different instruments in it. And we have a bunch of different specialists who are all on the OSIRIS-REx mission. That one, this is all brand new to me as well. I don't remember the name of it off of the top of my head. It's one of the things that I'm going to be spending the next 2 years learning very specifically. But yeah, it was, we saw a sample of another meteorite, and they could line up the atoms so that you could kind of like look down them, the columns of the atoms all lined up together, and you could see the different sizes. Um, yeah, it was,
That's
I wish I could describe it better. It
no,
was
it's so
almost a year ago that we saw this.
I'm pretty sure it's some sort of X-ray imaging, because you need to have an extremely small wavelength of light so that the wavelength of light that you're using is smaller than the things you're trying to image. I don't think scanning electron microscopes quite have that resolution, but I could be wrong. Um,
Yeah.
and I have to say I still have my 3D printed Bennu on my desk.
Oh.
With the one giant nubbin of a rock sticking out. Um, that we avoided with you avoid. I had no part of that. That you avoided with the spacecraft, and all these models were 3D printed by the Planetary Science Institute's printers, and we just got a donation of $1.42 to make. We have a continuing palindromic um, donation. It is currently 6699.66. This is an excellent total donation to have, although I have to say at some point I'm hoping it's $7,000.07 and I get a screen capture of that, because that would be pleasing. So it, of course, 711117 and all those other numbers. Um, so we have about 10 more minutes before we go to Mines on the Nines and check on what's going on in Minecraft as they continue to build their scale model of the solar system with a Jupiter that is 256 blocks across and beautifully painted already. Um, you're setting up the lab, and I'm I'm assuming that when the sample comes in, you're going to find that you have different sized bits, different kinds of bits, and you have to split the bits up between multiple institutions. How do you figure out who gets what? And I know there's already like contractual agreements in place on which percentages go what places. But how do you decide to split the rocks? It seems kind of like Solomon's baby.
Yeah, I mean, one of the things that we're doing right now is we're collecting information about the scientists who are going to be analyzing the sample, what instruments they have access to, what kind of data they want to take, and what kind of analysis they want to do, what the input for that is, because some instruments take dust, some take powders, some take thin sections. You know, some analyses are destructive to the sample and some aren't. Some they need to put some sort of material on the top and then take it off, which might, a coating, which might, another scientist might not want on that. So it's a massive amount of organization. And ultimately it's mostly up to the JSC, Johnson Space Center curation team, I think, to do the actual parsing with some input from OSIRIS-REx and Dante. So luckily, it's not most of us who have to decide. But yeah, it's a massive undertaking to figure out who gets what when and how to do this really efficiently.
But it sounds like, and this is something that hopefully everyone assumed was going to happen ahead of time, but it's always good to confirm assumptions that if you have those 3 grams of powder, those couple of pebbles, and those two gorgeous larger things, the larger things go to the people who do the thin sections. The powder goes to the people who want to destroy things or look at powder. And then everyone just kind of looks at the gravel and goes, huh, okay. Does
Hmm.
that,
Yeah,
it's,
that seems right to me. Yeah, I mean, luckily what we have, this was going to be an incredibly hard process if we had
yeah,
ended up with 60 grams or maybe less. If we had come back after multiple sampling attempts and just couldn't secure enough sample, this was going to
yeah.
be a really hard decision. But I feel like what's going to end up happening is that there is going to be a lot of sample, and anybody who needs something is going to get what they need. It's going to be joy all around.
That, that is amazing.
Yeah.
Now, one of the problems that we've all faced at one point or another, if we're funded by NASA and a spacecraft, is they don't release the funding for certain activities until either your spacecraft is launched or a sample has been taken. And I've seen these amazing images of the labs that were created for Hayabusa 1's sample that are now being reused with Hayabusa 2.
Mm.
Are the labs at the University of Arizona already under construction, or is there about to be a massive building project going on around you?
They are definitely already under construction. And also, the University of Arizona already had a well established microscopy lab, because they have, the Lunar and Planetary Lab has been
Yes.
around for so long and they've done meteorite studies. Um, and they already did have funding to build a new lab, which is under construction. I don't know off the top of my head how much more construction and building and instrument acquisition they're going to do. Um, but yeah, it's definitely already underway. Even before we got the funding for the next phase of the mission.
That's awesome. Larry Weird is asking, did you get a door closed or something, or did you just origami around the sample to keep things from continuing to escape?
I think we just tried to stop moving so much. Yeah, we are hopefully not losing too much, but
Yeah,
yeah, you saw those pictures.
I did. I did. And I've always kind of thought of the tag arm as an angry vacuum cleaner that
Mm.
just basically pops out and spins and pulls things that it has blasted out of the surface. And sorry for hitting my mic, audience. Um, and with a vacuum cleaner, when you turn off the suction, everything has been drawn back into the vacuum canister except for what's still in the hose. And you can shake the hose, and that penny you didn't mean to vacuum up will fall out. Is there a similar, you're basically losing what's in the hose going on, or is it more terrifying?
It is more, so if you look at the images, it almost looks like, and this is, we're just looking at images, so
Yeah.
the same as everybody else, but it
Yeah.
almost looks like you can see particles in the sample
Yes.
head. And so the theory is essentially that those are the mechanism that is supposed to keep everything up, which is kind of like a mylar film,
Uh-huh.
is being propped open a little bit.
Okay.
And which is great because that means we have so much stuff that it's overflowing. But that could be why things are kind of slowly escaping. And which is
And
why we don't want to do any more moving and any more spinning. And
exactly. Exactly. Now, are there more things that will close in around that than just the Mylar film as you pack up to come home?
So we're going to put it in the sample return capsule, which
Okay.
is a little dome. If you can kind of see it on the outside of the spacecraft. And that's going to seal it up, airtight. And that's actually what's going to be ejected from the spacecraft when we get back to Earth. So that's going to go through the atmosphere. It's going to crash into the Utah desert. So that thing is basically a beast. And so once it's sealed up inside of there, that stuff is not going anywhere. So we just need to get it into the capsule ASAP, and guarantee that we're not going to lose any more samples.
There's a fabulous phrase Asteroids wrote: the spacecraft eyes were bigger than its stomach.
Mm. Yeah, but we're happy about that.
Yeah, yeah, I
We gave
think
it its
so.
all.
I think so. I think
Yeah.
so. So it's been amazing catching up. I can't wait now
Yes.
that things are starting to calm down to get to just work on getting science out of everything that
Hmm.
we've been doing for the past several years.
Yes.
This
It
luckily
will.
was not a long duration mission. I look at the poor folks doing Beppo Colombo who named their mission in 99 and it still hasn't got
Mm,
there. It's awesome.
yeah.
And there's
Couldn't have
more to
asked for a
come.
better outcome.
Yeah. It's it's been great getting to know you over all these years as we dealt with so many different things, and
Yeah.
the patience, the creativity, everything else has just been amazing. And I look forward to seeing what all you and the rest of the OSIRIS-REx team come up with in the coming years. Is everyone on the mission now going to just sleep for a week?
Oh, that would be wonderful. Oh, they're gonna furiously write all those papers they weren't able to write over the last few years.
That's fair. That's
Yeah.
fair. All right, so we're getting ready to go to Minds on the Nines. Do you have any final words of wisdom or science or anything else as you head off for the evening?
I mean, it has been so incredible to experience the support of the scientific community and just the scientifically interested community, as we've gone through this and gotten the cheers of support on Twitter and Instagram and through events like this. Um, it really, I mean, it's hard to be on a mission. It's amazing, but it's hard. So knowing that
Yeah.
people support what we do and are also excited it means a lot.
We hate rocks now. We hate rocks, but
Yeah, a
we
lot
love
of
the
you all have
spacecraft.
suffered as much as we have.
We love the spacecraft. We hate the rocks. Grind them up all you want in your lab. We're good with that.
Yeah.
Make them suffer.
Yeah, I guess it's good that OREX gave it a good punch for all of us.
Yeah, it deserved it. It had it coming. So I'm gonna bid you adieu, and we're gonna go and see what's going on in Minecraft. Thank you so much, Karina. It's been a
Thank
pleasure.
you.
And now we are once again in the welcome, well, at the welcome center to our Minecraft world. Thank you so much, Kiefer, for coming back and showing us, well, showing us all the
Yep.
flowers that are growing.
All the flowers that are growing. So this is our welcome center on the overworld. So Earth, if you will. We had lots of landscaping done. We've got flowers growing, but we've had a lot of new developments in the neighborhood. And so I'm just going to show you our launch structure here. Our launch gantry is having a rocket of some sort built to be launched from the pad. Our space shuttle now has a runway. This is new. Oh, we apparently have a golem. That's just amusing. Two golems.
we have golems in the runway.
We have golems in the runway. They weren't there earlier. There was some reconstruction done here at the library that involved a certain amount of TNT, I understand. Hexacosacoron, one of our community members, has built.
That's gorgeous. I saw it starting earlier, but it was like up in the clouds.
Yeah, the clouds appear to have cleared through. But what I noticed, which I don't remember from earlier, the last time I looked, is it's kind of set the grass on fire. But that's okay.
It's getting ready to launch, but it just hasn't built up quite enough pressure yet.
That, or yeah, because this wouldn't have landed like this. So yeah.
And I have to pause and ask a personal question. Are you walking around with a diamond tool in your left hand and flowers in your right?
I apparently have. What do I have in my hand? I have a nether star in one hand, and I apparently have blue orchids in the other hand.
$1,078.11.
Wow.
Which gives us 7777.7. I should not be pounding my table. We have a complete palindrome of $7,777.77. You have taco catted it beautifully.
Wow, thank you very much. That's awesome.
That is so. I don't know who you are. I had said that if we hit $10,000, I would do custom paintings with people. We haven't hit 10,000, but I'm going to tell you right now, you and I, if you're up for it, are going to do a Zoom session, and I'm going to paint a world of your choosing. And thanks. You just made it a lot easier for me to keep my staff fed, and thank you.
Yeah. Thank you so much.
I love this little world. It's the Calico world.
The Calico world.
I'm still so happy.
The patchwork world.
I have a dog.
I
have a dog and I have a granola bar. Come here. Oh. So we show gratefulness with dogs. The other dogs are all like, I won't jump on you. I want some too. Okay, continue your tour while I give munchies to dogs.
We're gonna run through the planets. We're gonna go and look at Venus. Venus is over here. I think Venus is done. Venus looks almost done.
I love the atmosphere they're putting on it.
Yes. And who is that? That is Kieri.
Oh, yeah, it's a planetary scientist out there doing awesome work.
Yep, one of our planetary scientists doing, making sure that Venus looks correct. The atmosphere goes on top, she says. Earth. Earth has undergone a lot of, updates. We now have North America, South America. We have Europe and Africa and most of Asia.
And even the Philippines.
Yep, and the Philippines, and we have New Zealand, I think, was over there. We have Antarctica. And then we get around here. And yeah, we have some creative geography going on the back. But it's all okay. There's still people putting final touches on it, I think. We'll take a look at the moon because the Earth is not complete without the moon.
So
And a
many
little
Easter
lander.
eggs.
Yeah,
Sheet.
I believe so. See, it's got a sign on it.
It's a sign in Hebrew and
Small country, big dreams. IAI Space IL X Prize.
X Prize.
Yeah.
That's awesome, even if it is dead coral, which slightly disturbs me.
Well, it's good colors. Back to the center of the sun. Mars. Oof. So we have Mars. We're going to go around Mars this way. And there's Phobos. Itty bitty little Phobos. And we have a volcano and we have potatoes. Ah, they've labeled Deimos. Itty bitty little Deimos. And then we have
So I just had someone hand me a bag of dog treats.
Oh,
and
yes.
Eddie is cramming his head underneath my monitor to try and get at the dog treats. So in a few minutes, we will be doing a handoff between me and Annie for hosting. And before we do that, we will do a celebration of dog treat goodness. Stella is currently left out because she's much smaller and less aggressive about getting the treats. Okay, continue. I'm sorry for the distraction,
okay.
but I had chaos over here.
So we've got, this is our asteroid belt staging area. Yes, this is the asteroid belt, Ceres Bennu, they're out here. We have Ceres, which looks like it's made out of dead coral.
And that's okay.
Oh, and we have a blue block there. And we have Bennu. And you just spent a lot of time talking about Bennu, didn't you?
Yes, and we just got another $22 so that we continue to have a palindromic taco cat of a set of donations. We're now up to $77.99 and 77 cents.
Nice.
And I deeply appreciate that Bennu is rocks on boulders.
And little buttons that you can push. And it says, Bennu, why? And a blue block. And who else is out here? Shall we go check in on Jupiter? We're told that this is a coincidence. I don't know, Pamela. What do you think?
I'm still seeing, like, it's looking more and more like a raccoon in a ski cap and jacket with ski poles.
Yeah.
I totally see a skiing raccoon.
I'm assured that it's just a coincidence. Saturn. So Saturn has rings. Saturn is huge. And our artists are starting to leave little signatures in their art.
That's
As you can
so
probably...
beautiful. And then there's a screaming face.
Yeah, I think it's a happy face.
That
It's hard to
is
say.
so detailed. Oh, wow.
And that was by Sloth Chick, who is one of our Minecrafters, or one of our younger Minecrafters, I think.
Oh,
And Thieping.
the texture that is in the eyes. It's sculpted. It's amazing.
I'm not sure what they've used.
I don't know, but it's
Yeah,
pretty.
and I'm not going to poke at it because I'll break it and then I won't be able to put it back together. But we'll take a look. We'll try and give you an idea of seeing just how big it is. I mean, you can see the rings heading off from Saturn over here on the right side of the screen. Way out there. Like, that's a long distance in Minecraft. I've kicked in high speed and it's still taking a long time to get there. And I've gone so far away that it's not even rendering.
That's crazy.
Yeah. We've got some very talented people here.
We really do.
I'm actually just going to skip out to Pluto.
Okay.
Because we've got a couple of blue planets.
Yes.
And that's pretty much where they're at
blue.
right now.
Yeah.
They're blue.
They're blue.
But we've got here Pluto with its little heart.
I love the little heart. I didn't understand it the first couple of times, but now I will never unsee it.
Yeah. And so then we have its moon, Sharon. Oh. And someone's added a sign. Rule
Tim
14.
was right. Yeah. That's awesome.
Yep. And that's a good place to stop in our tour around the solar system tonight, I think.
Yeah.
It's been many, many hours. I don't know how many millions of bricks we have played so far.
But we have amazing.
A colossal number of bricks, spanning millions and millions of bricks across the Minecraft world.
It's awesome.
And we're not done yet.
So
we're getting closer.
In just a moment, we're going to switch over to a stream hosted by Annie and Beth, who are going to be making cosmic-looking mocktails. Before we do that, just in thanks to everything that you guys have done while I've hosted all day, I'm going to bring you a moment of absolute silliness. Currently, you see on the screen a sleeping 30-pound Australian Shepherd who is about to be joined by our substantially larger colleagues in crime. Wow, we're getting side-eye from an Aussie. So hold on just a moment. I'm gonna take down my camera, transition to pure happiness, and then we're gonna go out with rockets, and you're going to get picked up on the other side by Annie Wilson and Beth Johnson. But first, let's do a happy dance of doggy, they have no idea what's coming, joyfulness. Do you want a treat? You do. You do. Let's say hello to everybody. Let's say hello. All right. Back here. Back here. Over here. Over here. Sit. Oh, you missed. Oh, that was me. Over here. Come over here. Come here, Eddie. Up. All of you over here. Over here. Come on, over here. Sit. Turn around. Sit. Look at the camera. You're getting too close. All right, I think this is all the silliness we're going to get right now. I'm going to throw out the traditional Cheerios. Sometimes you just need the pure joy of, there were more donations. Oh my goodness. We're up to 800. Good. I can't number. I can't do numbers. People, you've defied my ability to say numbers. We are up to the non-palindromic, not a taco cat, but still amazing number of $8,005.78. This is a lot of science, people, that you are making happen. This is an amazing way for me to end the night. I am so totally going to need to mop in here, but you know, it's worth it. It is worth it to see the sheer joy of doggos. So I am going to bid you all adieu. Oh, wow. Topical Tom, you're giving us non-happy news. So hello, Econ Greg. Thank you so much for being here. And oh geez, Eddie heard me say thank you and he came running looking for treats. So thank you all for being here. Don't go anywhere. I'm going to switch hosting over to Annie Wilson, which means the feed will drop for just a moment. I'm going to start the rockets. And Annie, if you jump into the voice channel, we can do a 3, 2, 1 switch. And the night continues. And I'm going to go hop into Minecraft for a few minutes.
You mean like this?
Yes. Okay, we have an Annie in my ears. She's not on the channel. She's in my ears, though. So I'm putting up the rockets, and you'll have Annie and Beth in just a moment.
Do 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 do.